For decades, scientists have pursued the holy grail of clean energy, nuclear fusion. It is the exact process that powers the sun and the stars. If we can successfully replicate it on Earth, we will unlock a source of infinite, carbon-free electricity. Today, we are exploring how fusion works, why it is so difficult, and how close we are to turning it on. To understand fusion, we must contrast it with today's nuclear power, which is fission. Fission works by splitting heavy uranium atoms, releasing energy but leaving radioactive waste. Fusion does the opposite. It squeezes two light hydrogen atoms together until they merge into helium. It creates zero long-term waste and has no risk of meltdowns. The Sun is a natural fusion reactor. At its core, gravity creates immense pressure and temperatures of 15 million degrees Celsius. Hydrogen nuclei naturally repel each other like matching poles of magnets. But the Sun's gravity squeezes them so tightly that they have no choice but to collide, fuse, and release the energy that warms our solar system. Because Earth lacks the Sun's massive gravity, we cannot squeeze atoms with the same pressure. To force them to merge, we have to make them move much faster. This means heating the fuel to an astonishing 150 million degrees Celsius, 10 times hotter than the core of the Sun. At this temperature, fuel turns into a churning plasma. At 150 million degrees, plasma will melt any physical container it touches. To contain it, scientists use a three-step process. First, hydrogen fuel is injected into a vacuum chamber. Second, it is heated using microwaves and electrical currents. Finally, powerful electromagnets create a magnetic field that suspends the plasma in mid-air. The most successful design for a magnetic bottle is the Tokamak. It is a vacuum chamber shaped like a giant donut. Electromagnets wrap around the chamber, creating a twisted magnetic field that forces the plasma to flow in a continuous, endless loop. As long as the plasma stays centered in the donut, it cannot touch the walls. An alternative design is the Stellarator. Instead of a simple donut, it uses a twisted, figure-8 ring. This shape is incredibly complex and requires non-symmetrical electromagnetic coils. While harder to build, the Stellarator keeps plasma stable without needing an internal current, making it ideal for continuous operations. The ultimate goal of fusion is achieving net energy gain, measured by the Q factor. Q represents energy output divided by input. If Q is less than 1, we are losing energy. The historical record for magnetic fusion is a Q of 0.67. To make commercial power plants viable, we need to achieve a Q of 10 or higher. Fusion fuel is virtually infinite. The reactor runs on two isotopes of hydrogen, deuterium and tritium. Deuterium is abundant in seawater. Tritium is rare, but we can make it inside the reactor using lithium. A single bathtub of ocean water and the lithium from 2 laptop batteries could generate enough electricity to power a home for 30 years. Fusion faces monumental engineering challenges. Merging atoms releases high-energy neutrons that bombard the reactor walls, making the metals brittle. Furthermore, we must cool the superconducting magnets to near absolute zero, right next to plasma that is 10 times hotter than the Sun. Balancing these extremes is a massive engineering feat. The leading fusion project is ITER, a collaboration between 35 nations building the world's largest Tokamak in France. It stands 10 stories tall and weighs 23,000 tons. ITER is designed to prove we can achieve net energy, paving the way for the first grid-connected demonstration power plants in the late 2040s. Nuclear fusion is the ultimate clean energy solution. By replicating the Sun's engine on Earth, we can unlock infinite, clean electricity to run our civilization. While the engineering challenges are immense, the progress we are making brings us closer to a future powered by the stars. What do you think about fusion? Let us know in the comments below. If you want more simple science explanations, subscribe to Layman's Field, bringing knowledge for everyone. We will see you in the next video.